Good day everyone. Today I'm going to explain about dynamic system stability based on frequency response analysis. Learning objective after this lecture is students should be able to solve problems about dynamic system stability based on frequency response analysis. For example, like problem 1, given the G open loop is equal to Kc over S times 2S plus 3 times S plus 2 square. If Kc equal 1, then A. Write a formula that can be used to calculate the amplitude ratio and phase value as a function of omega. B. Calculate the value of amplitude ratio and phase on various value of omega, and for this calculation use 4 to 5 different values of omega. C. Draw a both diagram sketch. D. Is the system with Kc equal 1 stable according to both criteria? E. With Kc equal 1, calculate the value of Gm and Pm. And if the value of Gm equal 2, then calculate the value of Kc and Pm. If the value of Pm equal 45 degrees, then calculate the value of Kc and Gm. For number A, write a formula that can be used to calculate the amplitude ratio and phase value as a function of omega. First, look at the equation of open loop given. Kc is over S times 2S plus 3 times S plus 2 square. When we look at table 10.2, the summary of common transfer function, we should make this transfer function become like in the table. So we should divide this become plus 1. By divide it into 3 and times it into 3, or divide it into 2 and times it into 2. So this is just the same as 2s plus 3, and this just like s plus 2 square. So the new transfer function model is become like this. Kc over 12s times 2 over 3s plus 1 times 1 over 2s plus 1 square. And when the Kc is equal 1, so we should change this Kc equal 1. The transfer function become G open loop equal 1 over 12s times 2 over 3s plus 1 times 1 over 2s plus 1 square. Okay. From this transfer function, we can divide it into 3 parts. Part 1, Part 2, and Part 3. And we look at the table 10.2. Part 1 is like the transfer function of this. Part 2 is like this transfer function, and part 3 is like this transfer function. So for the amplitude ratio, we can check from this equation. So for part 1, it become 1 over 12 omega, where A is equal to 12, times part 2 is equal, where K is equal 1 over square root of 2 over 3 square times omega squared plus 1 times part 3 is equal 1 over square root of half square times omega squared plus 1, and we square it where the n is equal to 2. And for the phase angle is using this equation, where for 1 over 12s become minus 90 plus tan minus 2 over 3 omega plus 2 tan minus 0.5 omega. And for B, calculate the values of amplitude ratio and phase on various value of omega. For this calculation, use 4 to 5 different values of omega. First, we pick our values of omega, where is 0.01, 0.1, 1, 10, and 100. With the equation of AR from the previous slide and also the phase equation from the previous slide, we can insert the omega that we have picked and insert it in these two equations. And we got 5 values of AR and also 5 values of phase. And also for the decibel, the equation is 20 log amplitude ratio. So we got a table of omega, AR, decibel, and also phase. And C, draw a board diagram sketch, and from the sketch is the system with Kc equal 1 stable. Okay, we make the script from using MATLAB with the transfer function equal G open loop equal Kc times 1 over 12s times 1 over 2s plus 3 and times 1 over s plus 2 square. For Kc equal 1, we can write the G1 for the transfer function of 1 over 12s, where this is for the numerator and this is for the denominator. G2 equal transfer function of 1 over 2s plus 3. G3 equal transfer function 1 over 1s plus 2. And we can make an equation of G open loop equal G1 times G2 times G3 square. And if we want to know the values of Gm, Pm, omega Gm, omega Pm, we can use this equation, and we can also plot the board diagram of the G open loop. It becomes like this. And we can also get the number of Gm, Pm, omega Gm, and omega Pm from the MATLAB. And the question is the system with Kc equal 1 stable? And the answer is yes, it is stable because the system of value magnitude is less than 0 at the phase equal to minus 180. So when the phase is minus 180, the magnitude is minus. The value is less than 0, so it is stable. With Kc equal 1, calculate the value of Gm and Pm. If we want to find Gm, the steps are: first, the phase value is equal to minus 180 degrees. From the value of phase, we can know what is the omega G by solving this equation, where the phase equation is from the first slide, where we get the Gm is equal to 1.04. After that, we get the values of amplitude ratio, where we use the omega G in the AR equation. which is the value of AR is equal to 0.05. And last, we get the value of GM, which the equation for GM is equal to 1 over AR. And the value of GM is equal to 19.45. And if we want to find the PM, the steps are, first, the AR is equal 1. We pick the number of AR equal 1. Then we solve this equation of AR where we can find the omega PM. The omega P is equal to 0.08. And next, move to the phase equation where we insert the omega P in the equation and we get the phase is equal to minus 97.92. And last, we get the value of PM with the equation of PM is equal to 180 degrees minus the number of, or plus the phase value, equal to 82.0705. If the value of GM equal 2, then calculate the value of KC and PM. Okay, first, the GM is equal to, then we calculate the number of KC first, where the steps is AR is equal to 1 over GM, so we know the number of AR is equal to 0.5. Next, we can also insert the value of phase equal 100 minus 180 degrees, and we can know the omega G by solving the equation of the phase with minus 180 as the phase value. We get the omega G equal 1.04, and the Kc, we get the number of Kc by inserting the values of AR equal 0.5, the omega G is equal 1.04 into the AR equation. And the Kc is still Kc because from the previous question, we put the Kc is equal 1. So in here, we should find the Kc first. So we get the number of Kc equal 9.7. And next, after we get the value of Kc, we should find the value of PM. With the Kc equal 9.7, so the equation of AR will become 9.7 over 12 omega times 1 over square root of 4 over 9 omega square plus 1 times 1 over 0.25 omega square plus 1. With the AR is equal 1, we can get the value of omega P, which is 0.66. Next, with the phase equation, we can get the phase value, which is minus 150.8. And we can get the value of PM equal 29.19. Last one, and if the value of PM equal 45 degrees, then calculate the value of Kc and GM. First, we should find the value of phase, which is minus 135, and we can get the value of omega P by inserting the phase value of 135 to the phase equation, and we get the omega P equal 0.48. With AR equal 1, we can get the number of Kc with the number of omega p equal to 0.48 and AR equal 1, we can get the Kc equal 6.44. Next, from the value of Kc 6.44, we can get the omega g with the phase of minus 180 degrees. We get the omega g equal 1.04. The amplitude ratio equal to 0.33, and we get the Gm equal to 3.01.